Hi everyone. How you doing? Very formal. This is the introduction part where I say, hello, my name is Richard. This is the Technical Debt Prevention Clinic. I was going to be really cheesy and wear like a lab coat and a stethoscope or something like that and say, the doctor is in, but let's face it, there's only so much you can do for a dead patient. All right, so introductions. I'm Richard. There's my Twitter handle, email, all that sort of thing. Feel free to hit me up on any social networks, ask questions, all that sort of stuff as you would. Just in terms of background, I tend to do a bit of talking. I run the alt.net group here in Sydney with a few others. So who comes to that? Just who's a local? So you guys already know what you're in for. Congratulations. I don't know why you're here again. I also am a Microsoft MVP, principal consultant with Redify. I've written a couple of books. I do Scrum coaching and training as well, so I'm a Scrum.org accredited trainer, which basically means I have no social life at all, and I don't know why I do this. So we're going to get into it, because what you're really interested in is the content of the talk, not me, and here's what we're running through. So we have to do the structure to start off with. Basically, we're going to cover off what technical debt really is, not what you think it is probably. What it's all about, how we end up with it. Most of you know how we end up with it, right? We write code. Good. Then how do we quantify it if we can? How do we reduce it and reduce the problem? And then preferably, how do we actually prevent it being a problem in the first place? So that's the intent. You're all with me so far? You haven't fallen asleep after lunch yet? Still time. Cool. All right, so tech debt, what's it all about? It's a metaphor. Nothing fancy, it's just a metaphor. In the industry, you might have noticed we like to take our metaphors and make them bigger than they are. Metaphors are just things to explain a concept. We've turned it into this thing, and now people go crazy with it and actually try and put dollar values on their technical debt, all sorts of stuff as if it was real financial debt. I mean, it's just a metaphor. Now, the question is, where did it come from? Because we really should understand where this whole thing came about, who started the idea and so forth. So, a guy named Ward Cunningham, anyone heard of at all? Few of you? Awesome. At an OOPSLA conference back in '92, being the Object-Oriented Programming Symposium of Los Angeles, it's great, said this. So, although immature code might work fine and be completely acceptable to the customer, excess quantities will make a program unmasterable, leading to extreme specialization of programmers and an inflexible product. I'll put my teeth back in. So, being a clinic, let's diagnose the patient. Who's got an inflexible product? Thank you for your honesty. The rest of you, you're all liars. Do you have specialized programmers, guys or girls who know just that bit and no one else does? Anyone? A few more hands. Good, we're getting there. All right, and do you have immature code? Did you write it today? Hands keep going up. These are all problems we have. Now, the metaphor is this idea that shipping code for the first time is like going into debt. This is the metaphor, right? A little debt speeds development so long as it's paid back promptly with a rewrite. So, a little debt speeds development. Interesting. Who has a little debt? No hands. All right, I'm going to ask the opposite question because I like to be scared. Who has a lot of debt? We didn't even have to quantify that. You just go, yeah, we got heaps. Who's got those parts of the code base that they just don't want to touch because every time they do, it's, yeah, okay. Yeah. And who blames the previous person for writing it? All right, so what Ward's saying with this metaphor, two hands, nice. What he's saying is that technical debt is good. Technical debt treated well is good because it lets us deliver faster to our customers. It lets us put something in front of our customers that works well. Remember, we said it's immature code, but it works. So we're able to put something in front of our customers to learn from it. So we get earlier feedback and we can then use that to improve our design and then the value delivered over time and our maintainability and all those sort of things. Does this sound familiar to anyone? Yeah. Now what happens normally, by the way? Yeah, we stop there, yeah. We write our proof of concept code and what happens to our proof of concept code? Ship it, it's production. But if we think technical debt is good, if we were to use someone else who's not Gordon Gekko, we would say something like, technical debt is, for lack of a better word, good. Technical debt is right. It sounds terrible. You really got to do it with a bad accent. Technical debt works, it clarifies, it cuts through and captures the essence of the evolutionary spirit. This last bit, cuts through and the evolutionary spirit, is what we want in agile software development. We want to get stuff in front of customers, get them using it, see if it works or not, clean it up a bit afterwards, pay back our debt, and then carry on. Which means that technical debt is a healthy part of an agile team. Who's doing agile development of some variety? Who's doing cowboy development, pretending it's agile? Good. Who's doing waterfall development because they still work in a really large organization? And by really large, I mean government. Am I close? Am I close? All right. Technical debt is not this. This is what most people think of as technical debt, the quick and dirty stuff. That's not technical debt. Quick and dirty is not a way to just slap stuff out there. Yet the blogosphere, because no one's used the word blogosphere for a while, so I thought I'd crack it out for another try, took that technical debt metaphor and confused it with the idea that you could write code poorly with the intention of doing a good job later. I'm thinking that was the primary source of debt. Now, the person who said this is, again, Ward, talking about other people's interpretation of just a metaphor. Does this seem a little too close to home for people? The road to hell is paved with? Yeah, absolutely. So these are problems. There's a whole lot of stuff here that you can think about in your day-to-day where you intend to do something well, like our proof of concept code, and then we put it out there and we have to move on to something else. And we never come back and clean things up. Ward says this, though. He's never in favor of writing code poorly. He's in favor of writing code that works and is good, but that reflects your current understanding, even if that understanding is partial. This comes back again to the idea, I write something, I deliver it, I put it out there so that I can learn from it, adjust and adapt and inspect and adapt, I should say, and fix things up afterwards so that it is maintainable code. And again, a little debt is healthy. A lot of debt we drown in. Your bad code, as it turns out, is not technical debt. It's just bad code. Go on. Go on. Own up. Yeah, thank you. Keep going. I can't help you if you don't admit you've got a problem. Here's the other thing. Those bugs that you've got, that you go, oh, it's just technical debt. That's not technical debt either. Your bugs are just bad code that doesn't even work properly. Anyone again? Who's got, by the way, a technical debt backlog? Yeah? You've got a list of these technical debt issues that you want to clean up. Are they basically bugs? Copy and paste code, shoddy design, slap together stuff that you've just never cleaned up, proof of concept code that's ended up in production and you'll get to it later. What else is on there? Nothing. We've gone quiet. It's interactive. It's okay. Feature flags. All right. So technical debt means you've got easy to change, well-written code. Who's got technical debt? It just doesn't implement the full solution, right? So this is the idea. If you're doing technical debt well, you're doing iterative and incremental delivery. Agile development. It's what we want. So it's not these things. Own up if you got this. Quick and dirty. Yes, come on, a few more. Come on. Okay, maybe you didn't write it. Someone else in your team wrote it. Or a friend of someone who hypothetically had a friend who was hypothetically working in the same team might have written it yesterday. Copy and paste development. Stack Overflow-based development. Yes. Unit tests, as in you don't have them. Or you've got unit tests that break every time anything changes ever. Because your unit tests aren't unit tests, they're integration tests and extremely brittle. Or refactoring that you've left for later. That's not technical debt. That's just your bad code you haven't gone back, cleaned up. The bugs you'll fix later, mistakes that come from inexperience, low skill, carelessness, all these sort of things that happen. These are problems. Now, this is all bad code. All bad. Bad, 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 bad. It's not technical debt, but it's a problem. And the fact that it's just a metaphor means we really should deal with both problems. The proper form of technical debt and then all the rubbish that you guys have managed to produce. So let's quantify it. How do we quantify bad code? Any ideas? Is it possible? Can we actually quantify it? Can we get some unit of measure to say, yeah, this is how much we've got? How do you define bad code? Great question. So let's go subjective, right? So how do you quantify beauty? And how do you quantify ugly? Because when you look at some code, I'm not saying people here, by the way, but some code you go, that's really nice code, I like that. And some code you look at and you just kind of go, what the hell is that? That's code only a mother could love. So consider this. How much time do you spend on problems you could have avoided by doing the carpenter thing of measure twice, cut once? Last week, how much time did you spend banging your head on the table thinking, I could have done this, this could have been avoided if only someone had a thought first, or they had have done something a little bit better? Anyone more than 5 minutes? That's not many people. You guys don't, okay, managers, you're okay. Everyone else, what are you doing? Or the number of WTFs per minute. Now, you've probably seen the XKCD comic. And if you haven't, you know, we can do the Modern Family version of WTF, philosophy, the number of why the faces per minute. And it's actually really amusing. If you walk around a dev team and you just watch them working, you see them go through the different expressions, right? They bring up a bit of code and what do their faces do? What the? And then it's like, and then they go the double face palm. And then they start getting angry and they start getting sweary and their faces are tense. And anyone? Did I miss a few, by the way? No? The tears. I forgot the tears. All right, so there's plenty of these things that happen, right? You generally know based on these things. It's a subjective measure, but how good or bad some code is. But you can be easier about that. Instead of watching people, you can simply ask them. Let's grab every member of the team, come together. How do you feel about our code quality between a 1 and a 5? All right, so a 5, just to set the expectations, is this. Okay? A 1 is that. So 5s, 4s, why are you in the room? 3, 2, everyone else, you didn't even make the scale? I'm really concerned for you guys. All right, so they're very subjective, right? Now you obviously can do objective measures as well. You can look at things like code coverage and cyclomatic complexity and class coupling and naming issues and duplicated code, for your copy-paste development that we've never ever done ourselves, only someone else. And these are objective measures, and there's various tools that you can use to look at these things in your code base and see where stuff's at. Who's heard of SonarQube, by the way? Who uses it? Awesome. I love SonarQube. I'm into graphs and charts and things like that. I just love it. So being able to quantify and measure some of these things is great. It helps me understand what quality a code base is at. Now, I don't always agree with some of the measures in terms of where Sonar comes up with the number of days needed to fix things, especially when the number of days equals when the heat death of the universe is going to occur. But those sort of things are really useful in terms of understanding more the volume. The specific measure doesn't matter, but the volume of stuff that's in your code base. These are things we can look at. But there's other indicators as well. We could look at trailing indicators such as what's happening with our velocity. So our rate of delivery as a team is generally a good indication, all right? So if our delivery is going along nicely, everything's cool, we generally I would assume aren't picking up too much technical debt or bad code. It's not slowing us down. But if our rate of progress starts dwindling, odds are you're starting to struggle with this stuff. Sound familiar? Yeah? Who's got a velocity that's in the negative? Okay. System availability, how often your system crashes in production. How often do you have to bring it down because you've got memory leaks? How often are you rebooting IIS and restarting simply because you keep hitting the memory limit? No one has that problem, right? We don't do web applications. Or change that broke at their bugs. Now, come on, anyone? Again, you guys are great. It's only like 10% of the room that has this problem. Either that or you're working on really simple applications, or you don't actually fix the bugs. You just write them and someone else fixes them. Because if we don't have any tests, we don't know that it broke anywhere else, so we're gold. Staff turnover and attrition. Yeesh, this is a nasty one. If we've got problems with technical debt and bad code, we generally will struggle to keep people around because they won't enjoy their work. Which also affects your general morale, the passion of your team, and the overall happiness of your team doing the work. I'm not going to ask who's got this problem, because it's not always a code-related thing. That said, in a lot of organizations that suck, devs can generally be happy as long as the work is interesting. When the work's not interesting, even if it's a good company, the devs will tend to roll through and go, I don't need to be here, this is not a challenge anymore. Unless they're making their own challenges. And also other things like declining levels of skill and relevance. So if I've got bad code, one of the interesting side effects of that is that I can't move it forward and modernize it because I've got too much rubbish to deal with. I've got too much legacy to hold on to. So therefore, my skills tend to rot. And this is how we turn ourselves into the next version of COBOL developers. Anyone still writing .NET 1 code? VB6, by the way, I should check. A few of us. .NET 2. Anyone still have to crack out Visual Studio 2008 to do anything? Yeah. Just for fun. All right. Now, with all these things, you don't want to aim for specific measures. You're looking at trends over time. You're looking at how things improve over time. So SonarQube is good with that because we can see trends, but you can also do the same thing with your subjective measures, right? So again, looking at that quality question, if we ask the team, over the last N number of months, what's happened to our quality? Has it gone up? Has it gone down? What do you think? Are you happier with where we're at or not? Scary question to ask, but hopefully we have people saying this. A 5 is like, it's so much better, happy days, dancing in fields of roses and stuff. Well, maybe not roses, they've got thorns. Other flowers. Or, nothing's really changed, not a big deal, it's like we're just carrying on. Or, and if you think about your last 3 months, even that sort of time frame, which way would you be heading? And if you're trending down, you've got a problem. So, it's not a perfect measure, it's very much subjective. We've got some objective measures, but fairly subjective in terms of what we can look at. So let's have a look now at, once we understand the size of our problem, how do we actually do something about it? How do we reduce the bad code and the technical debt we have? So, who likes the technical debt sprint approach? Anyone done one of these? So most of you are doing Agile. I assume you understand what a sprint is or an iteration. Who's done a technical debt sprint? Got one coming up, nice. Okay, don't do them. What's the business outcome of a technical debt sprint? Nothing, correct. So how do you prove you made any difference? How do you prove that? Here's what normally happens, by the way, in a technical debt sprint. You have a whole lot of these big ideas. I've got 2 weeks. We've got so much we could do in 2 weeks. So we go off and we start writing stuff for our 2 weeks thing, and they're usually big efforts to change a whole lot of stuff. And we do them in pairs, maybe even. Maybe. Unlikely. It's usually solo. And everyone's going off and doing their thing. And the first person finishes their big restructuring of the code and they commit it. What happens to the rest of the team? They're going, no, I didn't win the merge war. So now they've got conflicts all over the place because they were doing restructuring as well, but they can't tell what should have been to where it is now anymore. The size of the pull request that this first merge went in was about, that big, and everyone obviously paid a lot of attention when they absorbed that merge. And so they just slapped it in, away we go. How do we prove that we didn't break anything along the way? We don't, because we don't have any unit tests, because who has time for that? And we end up with all this code that got moved around and changed, and now even if by some miracle everyone got their changes in, what happens the next sprint when you start doing normal work again? You start going, well, where's this gone, and what's happened to that, and I don't know what happened to my code base anymore, and now everything's all over the shop, and I sit there scratching my head. And as a team, we've now actually made it worse for ourselves in the following, not just one sprint, but probably 3 or 4 sprints. And any net time we might have saved in the technical debt sprint is pretty much eaten up by the delays we have in the following sprints, and there's no guarantee we've improved anything anyway. Don't do one. Don't. What about this one? Anyone doing a rewrite project? Ironically, I was quoting on one of these yesterday. But you know what the rewrite project is, right? This is I write the Netscape browser. Is that enough? Should I stop now? Everyone knows the story? So we're writing Netscape. It's really horrible. It doesn't do what we need to do. It's really hard to work on. It's terrible code. So what should we do? Throw it out and start again. Of course, a rewrite means do what the old thing did, correct? How's it usually implemented though? Do what the old thing did, but make it betterer. So what's the spec for betterer? Keep talking. Yep. Silence, good. No one knows? No one knows. It just means better, right? Better as defined by... And so we end up with this, it's a rewrite, so everyone starts piling on all their wish list stuff as well. And as devs, we're going, we can use all the new and shinies that we've never used before. So now we can write it in Angular 7 using JavaScript ECMA 74 and .NET Core 3.6 Service Pack 1, or whatever other random thing. And we should use some new design patterns because I read about these on the internet. And even though it's a desktop application, we should write it as a microservice. And we should deploy it with Docker because everyone wants to have Docker on their desktop for normal users, so we can run that because that would be cool. It's going to look great on my resume. Anyone got this one? Yeah. So the end result is exactly the same as before. You've got a new mess now. You've got your old legacy mess, and now you've got a new mess. And because your new mess is just as bad as the old one, no one's using the new one, so you're now maintaining 2 messes. Don't do that. The problem with these rewrites isn't the technical problem. It's a cultural one. You don't get into the situation where you've got bad code because of a technical problem. It's not just that you as devs write bad code, or we. I have to talk to myself every time I do this talk. It's a whole lot more than that. It's a people problem. Code is not the result of some thing that happens. Code is a result of us using our brains to put something on the screen. So what's the source of the problem? Silence. Everyone's going, he's talking about me. All right. So what should we do to reduce our technical debt? The boring stuff, right? The iterative removal of technical debt. It's not sexy, definitely not glamorous. It doesn't look great on a resume. It's nothing you can point out and go, that was exciting. Look at all that stuff we reduced. It's not easy. It's not quick. It's not simple. Always comes with a cost. And you've got to remember that like anything, again, abusing the metaphor, the bigger the loan, it takes longer to pay off. So if you've got really horrible technical debt problems and bad code problems in your current code base, it's going to take you a long time to fix that. Similarly, if you're only chipping away at it a little bit at a time, it's going to take a lot longer as well. Hopefully you're paying back more than you're adding every time, but sometimes that's not even the case. one person's going through cleaning things up, and the rest of the team of 8 is currently writing their own new forms of technical debt and bad code on top of it, you're never going to keep your head above water. But generally, you want to follow the Boy Scout rule. For those who don't know, that basically says leave the campsite cleaner than you found it. Do the same in your code. If you're changing a bit of code, you're changing a method or a class or something, and you see a problem in there, just fix that little problem and move on. Another way of looking at it is this. Same idea. As you're doing stuff, identify a change that's going to save the next person 2 seconds. 2 seconds a day, 2 seconds a week, it doesn't really matter. Any of those 2 second savings add up. And those 2 second savings aren't in terms of how long it takes to write code. Technical debt is not about how you write the code. Technical debt is understanding your code. So the cognitive load in your head, how much do I have to keep track of so I know what to change? So how long does it take you to figure out the spot to change? That's what we have to improve. Obviously, there's also the R word. Who knows the R word? Did I spell it correctly, by the way? Because I often see it spelt with a U. You can figure out where that one goes. So the idea of refactoring is a series of small steps. This is from Michael Feathers, who came up with the approach. Each of which changes the internal structure of the code without changing the external behavior. Most refactoring, which is the other form, is where you do a series of small steps where you change the internal structure of the code and you don't even bother about checking the rest of it. Just ignore that. You can change the external behavior as much as you want. Let's redesign the whole application because that's refactoring. Anyone take that approach or seen someone they work with do that? Yeah. That's not refactoring. We don't want that. You should not change the behavior of the code when you refactor at all. I should see no difference. Now, Michael talks about 2 forms, by the way. There are actually 2 types of refactoring. There's the micro and the macro. The micro is obviously the simple stuff. You're just improving those 2 second savings, improving the readability of what's there, fixing a naming problem. You know, so I had going back a while ago, and I'm going to age myself even more than it looks like at the moment. I used to do VAX basic programming on VAX VMSs. Anyone else with me on that? Yes, so we're going to get our walking canes and we'll walk out of here together. And very procedural code, but we were, in VAX basic, we had variable names, strangely enough. Had a guy who named all these variables within a procedure as temp1, temp2, temp3, temp4, temp5, temp2. Yeah, it's great. He had a long method that had up to temp 47 in it. Special. He went on holidays for 6 weeks and a bug occurred in that bit of code, and guess who got to fix it? It took me 2 weeks to figure out what was going on, and as I did it, I renamed all the variables so that I understood what they did, which is kind of useful. So I improved the readability of the code. That's refactoring, even way back then. Ironically, another bug occurred in that bit of code about 3 months later. And I was like, oh, that's weird. And they gave it to me to fix because I was nominally the last one to touch it. Guess what all the variable names were called? Temp1, temp2, temp3. The guy had come back from holidays, seen the change to his code, and gone and put it back to what he had before. This is before source control, by the way. You know how happy I was. I'm not fixing that. All right, so refactoring for bigger stuff where you hit multiple files, that's obviously a macro refactoring. Again, you're still not changing functionality. Okay, so this is how we're reducing it. Micro refactorings, do them as you do them. No problem, fire at will. It's all yours, ladies and gentlemen, go nuts. But the macro refactorings, on the other hand, you really in your team only want to have 1, maybe 2 of these active at any point in time because they're changing the structure of your code or they're making large changes that will affect the rest of the team. You need to make sure the rest of the team knows what those changes are. So if you have multiple of them happening at once, like in a technical debt sprint, no one's going to keep up with what's happening. The rest of the team can also still be delivering value while you're working through this or part of your team is working through this. But you need to make sure that the changes are well communicated and well understood by the rest of the team, otherwise they're not going to help. Okay? So limit yourself. Work in progress rule should be only 1, maybe 2 if they're in very discrete areas like a front end and a back end that are very separate. Generally, though, your rules for refactoring, hopefully this is fairly straightforward. Rule number 1, don't talk about Fight Club. Okay. If you don't have any tests, you can't really do refactoring. Anyone got code with no tests at all? Yeah. When you break it by adding tests. You have a gift. All right, so micro refactoring, if you're going to do it, make sure you introduce a behavioral test to prove the behavior of the code you're about to change. Change it, make sure the test still passes. Fairly straightforward, right? But note that make sure the test exercises the code you're about to change. Don't go, I know I wrote a test over there, it passes, and now I'm going to change this. That's cheating. And if it's a macro refactoring, it's very much the same approach. You introduce passing, hopefully, behavioral tests. You make your changes, ensure those tests still pass. Okay? You will want to rely on coverage tools to make sure you're hitting enough of it to give yourself confidence. If you do things that affect database structures and schemas, you obviously need to think about data migrations because a lot of us forget that stuff. And you also want to check your performance. I've seen a number of people do refactorings that have taken highly optimized code that they didn't understand, refactor it so they could understand it, and their performance went from really good to really less good. Because they started introducing N+1 queries to the database and all sorts of stuff simply because they didn't take the time to understand it. They just thought, oh, it's bad code. But it was good code that ended up getting optimized in the future, so you've got to watch out for that too. All right. Now, refactoring, feature flags. We had a talk on this just before lunch, which I did not know was happening before lunch. I went in and sat in it. Who was in that talk? Lots of horror stories. It was great. I loved it. Feature flags are a great idea. Everyone knows what they are, right? Just to check, if you don't, the idea is that we're enabling or disabling features in production independently from deployment, right? The functionality is not changing. I just want to be able to turn things on and off by setting a flag at runtime. Fair enough. And launch darkly, again, I didn't know they were talking before. It's kind of ironic. The sample code's something like this. You get your user. You call the launch darkly client and say, get me a Boolean flag, and there's the name of it. This is my user, and the default value is false. Fair enough. And if the feature is on, show the feature, and if it's not, do it off. It's basically glorified if statements. Nothing more to it than that. Really simple to implement, okay? How could that possibly go wrong? I can implement this with good, clean code and still drown in technical debt. How? Because I don't think about things properly. I can have too small or too fine-grained flags. I can have too many of them. Anyone dealt with an SAP programmer? Anyone? Because you were all smart enough to run away screaming. SAP is famous for having flags for everything. Configuration like you wouldn't believe. It's flag here, flag there, flag. Thousands and thousands and thousands of them, and trying to put anything together that works with that many flags is basically like taking your pile of Lego at home, throwing it in the air and hoping it lands in the shape of a house. Really horrible. So that can be a problem. Poor or misleading naming, because naming's easy, right? Everyone knows, the best way to name a method is to call it method 1. The best way to name a test is to test 1. So how hard can that be? And all variables should be named temp what? Yeah, correct. So poorly named flags lead to all sorts of problems. Duplicating a flag so that we have the same feature controlled by 2 different flags. So we actually have to set them both at the same time to make sure it's right. Otherwise, the system behaves inconsistently. Or repurposing an existing flag. So again, Knight Capital Group was mentioned in the previous session. They're the guys who managed to lose millions of dollars in 45 minutes. Simply because they deployed an app with a flag set, missed one of their servers, and it all went haywire. If you ever want to read up on that, it's hilarious. Makes you cry, but hilarious. Or not removing your unused flags afterwards, so you end up with all these things that get left in there. Out of curiosity, who's got source control? Okay, good, good. Who has people checking in commented out code into source control? Why? Why, for the love of God, why? Someone's going to look at that commented out code, and what are they going to do? Oh, should I remove that or not? Is that meant to be uncommented? Was that like test code that got left? Is it, my head just, don't do that, right? Same with feature flags. Once you're done, get rid of them. If the feature's stable, you're not going to kill it anymore, just delete it, gone. Or no documentation on what a flag does, why it's there, and who came up with it. There's all sorts of these problems. These things here can kill a team, not done well. The code can be good, but the code is immature. Yes, it works, but we haven't really dealt with it. So we were able to get the feature into production. We were able to get testing and feedback. We never went back and paid off our technical debt. We end up drowning in tech debt. Make sense? So that sort of thing, cleaning those flags up would be a macro refactoring, because odds are you're using those flags in multiple code files. So when you remove a flag, you've got to change here, 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 and here, and you've got to do some retesting. Fair enough. All right, on to the next part, prevention instead of a cure. All right, so let's see if you've had this conversation. Manager, don't listen. It's really important we get this new rule enabled ASAP, like really important, because it's just like a new condition in the code. It's a new flag, right? I've got customers ringing me up asking for this thing to be turned on and enabled or do this, and it's just like, you know, I'm getting called all the time. Can we just put something in there for them? It'll be quick. Just fix it up. We can do it later. Just get it in there, get it in production. We'll fix it up later, I promise. Anyone had that conversation or something like that? Yeah. And then, of course, our response as the dev team is, sure, you pay my salary? Sure, you can have whatever you want. I don't want to upset the boss. And what happens? Hey. So that promise, does that ever get fulfilled? No. Or this one, Dev 1 says, can you review my pull request? Dev 2 goes, sure, yeah, no problem. 15 minutes, 20 minutes later, have you merged it yet? Oh, wait, sorry, oh, I forgot. Yeah, give me a sec. And they open up the pull request and they see 48 files. They go, oh my God, really, again? This is too hard. I don't have time for this crap. Merge. And we're done. Yeah, you're fixed. Move on. Inside, I'm swearing at them. Outside, oh no, we're nice. We're friends. I hate you, but we're friends. Anyone done this? Okay, who's been Dev 1 though? All right. So here's the thing. That just introduced a whole bunch of technical debt and bad code. We gave ourselves the opportunity to let that get in there. And who's at fault? The manager? No. Dev 1? No. Who is it? I'm helping you out by pointing at you. All of us, we're all at fault here. It's our problem. Bad code only exists because of you guys. Well, not just you guys, it's also the guys next door, the guys upstairs, the guys who don't get to come to NDC. That's all their fault as well. We're all in this together, hand in hand and singing songs. The first step, though, to fixing all this is to admit we are the problem. Not that we have a problem, we are the problem. It's our problem. So what we really need to think about is why. Why did we actually let this happen in the first place? So you might think it's laziness. Anyone? Human error? Sure, human error happens. Inexperience and skills gaps, those occur. I get that. They're legitimate reasons, and we can't prevent that other than having team members around us to pick us up on it when it's a problem. However, mostly it's this. Mostly it's that conversation with the boss was a pressure situation. They put pressure on us and we didn't respond the right way. Or another team member put pressure on us to get something done. There was an implicit time pressure by saying, oh, didn't you do that already? And so again, we respond by going, yeah, okay, sure, just get it done, get you off my back. That pressure that we face can be external, like those situations, but it can often be internal as well. We want to do a good job. So again, those of you doing Agile, you do sprint planning, I assume, or something like that, unless you're doing the cowboy Agile, where you just kind of write bugs and hope it works later. Internal pressure is, we set an expectation. We could do it in this amount of time. We can do that. Sure, I can do that. I know it's only going to take me 4 hours to do that. You get to 3 hours and 30 minutes, and you're going, I have no idea what I'm doing. I have no clue what I'm doing here. I don't want to ask for help because that's embarrassing. So I start rushing. I start copying and pasting from Stack Overflow. I find somewhere else in the code base that looks similar, and I copy that across and I drop it in. And I don't bother naming things properly because I want to make sure I try and get it as close to 4 hours as possible so I look that I'm awesome. What am I doing? Seriously, what am I doing? Who am I helping? I'm not helping the team. I'm not writing good code. I'm not going to be maintaining it well. I'm actually going to reduce our velocity in the long run because I'm taking shortcuts now. All I'm doing is just adding technical debt and bad code for no reason whatsoever other than my own ego. We are the problem. Each and every one of us. So what we really need to do is not just refactor our code, we need to refactor ourselves. We need to think about how we do things and improve from there. So step one, you're all adults. You all put your pants on in the morning, most of you. Probably did both, right leg and left leg. You didn't put both legs in the same side. Be professional. You don't need permission to do your job properly. You don't. Often we do. We should get permission to see if we can write unit tests. Hello? Just write the damn unit test. It's part of development. It's part of being a professional and doing the job properly. I need to ask permission if I can go and refactor that little bit of code there. Just do it. Don't worry about it. Get it done. Things like definition of done, have those and stick to them. Be disciplined. Or as Henrik Nyberg, who worked with Spotify as an agile coach for a long time, says, just stop it. Now, he's saying it a lot rougher than I just did. His delivery is usually a bit firmer. But just stop it versus just stop it, I'll get in your face and headbutt you afterwards. Not that Henrik does that, by the way, if you're listening. But just stop it, right? No more excuses. Don't make excuses. Do your job. It's okay. It's what we're paid for. So one of the fundamental principles of agile development, this is Henrik again, is this idea of sustainable pace. If you're consistently creating bad code, what happens to your velocity? It's going south. Does that mean you're working at a sustainable pace? No. We often think sustainable pace means I do my 8 hours a day, right? Because I want to stay fresh each day. I want to stay awake and alert. Yes, that's a part of it, but if in those 8 hours I write a whole lot of crap, that's not sustainable. Okay? And it makes no sense. It's not agile. You're just going to kill yourself in the long run and you're going to tie yourself into a corner, right back to where we were with that technical debt metaphor Ward mentioned right at the start. In fact, if you don't do anything, no changes, your progress will tank. However, to make changes and improve, it takes us longer now. We need to be more realistic over what we can achieve. So that green line there, hopefully that comes across on the projector okay for you. But if we change and we start doing things properly, yes, we're going to go slower in the short term. But the area under the line for the green line is much higher in the long run than the red line. So yes, your manager might be upset with you that your velocity used to be 30 and now you're doing 20. What the hell is wrong with you guys? We're doing things properly now, sir. I don't want you to do things properly. Keep your velocity up. You see the problem? How do we respond to that pressure? Again, most of us will go, okay, we'll stop doing unit tests, or we'll just copy and paste again. All right, team culture. Support each other, right? So listen for the excuses. Here's an excuse. It was easier to add the extra code to this method than adding a new method. Trigger word. And it was quicker to add the method to this class than creating a new class because I ain't got time for that sunshine. Again, trigger word. So you're listening for easy, for quick, for I didn't have time. Excuse, 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 excuse. Versus I'm a professional, we do things properly. It will take a little longer, but the net result will be better. Okay? Now there are some practical things. Let's think obviously automate everything, CI/CD pipelines, make sure the tests that you do have are repeatable and quick. If you've got a whole bunch of tests that take 4 hours to run and break all the time, anyone? Who's got a test run, by the way, where it takes a long time and it's always broken? Always. Occasionally, without changing anything, if you rerun the test, it passes. Anyone? Yeah. Okay, not enough hands. Obviously, you guys aren't testing. This is really common. I actually know places where their tests are always red, but they deploy anyway because they look at the number of failed tests and go, that's within tolerance. Yeah. Editor configs. Anyone seen this? This is in Visual Studio for the .NET guys, but there's also editor config works across all sorts of browsers. So you can take away the tabs versus spaces argument. Anyone had this? Anyone still having it? Yeah. And there's all sorts of conventions. So you automate your conventions as a team, you take away the argument, you save time as a team. Improve your test design, which means obviously start by writing tests. Yeah. And avoid those implementation-specific ones. Tests that know all about the internals of a method and don't actually check the behavior. Because those are the ones that are going to break every time you change anything. So you want to avoid that. Then there's things like code reviews. Who likes code reviews? Yeah? Wow. Here's my approach. What's the value you get from them? Because here's what normally happens. In a team, you'll see when there's a code review, pull requests, all sorts of stuff. People generally think it's a waste of time. They have negative attitudes towards them. The large reviews, as we mentioned before, get glossed over, and all the risk that's in there gets put in, where we tend to focus on the small ones with a lot of attention to detail. It's bizarre. It's like this inverse effect. Reviewers themselves generally lack the context or the knowledge of what the change is, so they end up looking at stuff on screen and going, yeah, okay, I can see what happened. I don't know if that makes sense or not. I don't know if we've just implemented the wrong thing correctly. Don't know any of that. But we'll check it in anyway because it looks okay. Thumbs up. Or we're inconsistent within the team. Or personal preferences versus team standards kick in and we end up arguing over tabs versus spaces or temp 1 versus temp 42. The bad devs in your team choose the friendly reviewers to look at their stuff so they can get in. You know it happens. Or there's assumptions like the reviewer's going to check my work, so I'll throw it over the fence to them because I know that they're generally good at picking stuff up and I don't have to. Or you're the reviewer and you go, they generally write decent code, so I won't pay as much attention to it. Ah, yeah. Again. All right, now, that said, doesn't mean the idea is wrong. Maybe it's just their execution. So, thinking about how do we do peer code reviews better? Well, let's stop. Let's instead, just bear with me, try this thing called peer refactoring. Everyone's going, what the hell are you talking about, Richard? Okay, so the idea here is that I write some code that works, immature code that works, and I open that up for a pull request. I make my, I have my branch, I push it, say, please do this stuff. Review my code. But instead of reviewing the code, the reviewer has to refactor it instead. Improve the design of existing working code. So they then pull down my code onto their local machine, they review that, they do the refactoring, they push it back up, I then look at their stuff, see if it makes sense to me, we rinse and repeat until we're good and then we check it in. Your response should be that, right? This doesn't make sense, surely. What a stupid idea, get off the stage. But think about it for a second. If you're going to refactor code, you need to understand it first, right? Before you refactor it. You can't just read the diff log on the screen. Who does that, by the way? Honestly, keep going, there's more. I do it. On small ones. On big ones, I don't even look. You can't just hit merge and go. You've got to actually run it and check it. You have to compile it. You have to make sure the code works on your machine, not just on their machine. So you're ensuring some of these things are in play. It also means you have to understand the reason behind the changes. So now we have 2 people in the team at a minimum who understand what a piece of code does. So we avoid the knowledge silos. There's a whole lot of benefits to this. Kind of cool, I think. But I'm standing up front, I can say that. You can, in your heads, be going nuts. But it is still a slow process. So how do we eliminate the waste? Well, let's not do write the code, send it to someone else and bring it back. Let's do it side by side. What's that called? Ah, yeah. All right, so who likes pair programming? Here's how it works. One person codes, the other sleeps. Or 2 people fight over who's the smartest. Or one person codes in silence, The other person's watching, they're going, I don't know what you're doing, but I don't want to interrupt because you look like you're in the zone. Or an expert pairs with a novice. And makes them feel like a failure at life if you can't read it down the bottom. That's not good. That's not good pair programming. That's just embarrassing. Because you're basically doing it wrong. It's like trying to use the spoon and holding the big round end and eating with the stick bit. A guy named Llewellyn Falcon has this approach called strong style pairing, which is much more akin to what we want. The idea here is that if you want to get, that's his description, I'll just skip over it, but the idea here is that to get code to the screen, it has to go through someone else's hands. If I'm the developer, I'm not touching the keyboard. So I'm navigating and asking someone else to write the code. So add a for loop here, call the variable this, whatever else. When they want to make some changes, they give me the keyboard and I do it. So we're directing each other. The advantage of this is that we are both engaged in what's happening. I can have different skill sets without a problem at all. I can have a dev working with a tester and it's not a problem. And again, two people understand the code. We can refactor and talk about as we go, which means there's no more passive or silent partners. You don't have anyone having the opportunity to fall asleep. We deal with that uneven skill issue and we get rid of the need to do these long-winded code review processes. Because two people have already looked at the code and come up with an approach. Reduces our technical debt and bad code and gives us more opportunities to spot savings. So anyone done pairing, by the way? It's surprisingly rare even today. But you often find that if you're pairing with someone, you're watching them work, even if it's ad hoc. Anyone a mouser? You know, they want to hit debug, so they grab the mouse and they drag it ever so slowly up to the top of the screen and they click the play button and the application starts. And then to go to the next, hits a breakpoint, they do the step, they have to switch and they go up to the step button and click it and then click it. And you're like, just F10, F5, F10, step. Drives me nuts and I will actually grab people's hands and stop it. Get off the mouse because it takes time, right? I get frustrated, just move along. And that's part of those 2-second savings, right? They add up. But there's other things you can do. So a guy named Woody Zull went crazy with the idea and came up with this approach called mob programming. Who's heard of this? Okay. Mob programming goes way over the top. It says, don't do pair programming. No, there's not enough people involved. Get the whole team doing it. One keyboard, one screen, the whole team as a group. Now, the interesting thing is this actually works. This works really well. A lot of people won't do it because they can't get to pair programming. They're not going to get to this. But the idea, again, is that the person with the keyboard is doing whatever the others in the team are saying. You rotate the keyboard faster so people don't drop out. But again, there's a navigator and the rest of the team is talking about stuff and working through it. Everyone stays engaged. And we share our knowledge across the entire team now, which again means we don't need to do a code review because everyone has seen the code now. We don't need to worry about refactoring because everyone's seen the code and can talk through things as we're writing it. Our team collaboration improves, all those sort of things. And you might think it's going to be a slowdown. It's going to cause problems, it's going to cost more because the cost of software development is how fast people type, correct? It's not, it's about what's up in our heads. So, interestingly, there's all sorts of benefits that come out of this, apart from the shared knowledge and understanding the team morale and so forth. But there's also those 2-second savings again, the shortcuts that help us work through things quickly. All the boring stuff that you would manually do that takes time that no one else notices and you don't even notice becomes really apparent when we're doing it as a team and everyone's watching you fumble about with your mouse. So again, doing this is an interesting approach. So if you want to maximize the number of lines of code typed out by keystroke and stuff, then this isn't the thing for you. If you want to maximize the value and the collective brain power of your team and get them working well together, consider it. I'm not going to prescribe this. These are options to help refactor ourselves. The idea really should be you experiment with these approaches, find out what works with your team, and try and make that a part of your everyday. Because that will help prevent problems in the first place. Remember, prevention is better than a cure. So transparency helps us eliminate tech debt and bad code. The more eyes over it, the better. This is kind of that cathedral and bazaar thing with Stallman and open source, if you're aware of some of that as well. The more eyes on it, the better the code should be. There are other prevention techniques, of course. Limit your work in progress. Anyone doing Kanban approaches? Yeah, okay, so again, limit your work in progress, right? Because it helps us isolate our thinking to one task at a time. If we spread our thinking, we have context switches. Context switches cost time. Also means that we're not as in tune in what we're doing, and we were more likely to make mistakes. Bad code, tech debt. Short-lived branches, that should be obvious. No one wants to do the merge commit of a branch that's lived 3 months. No one. Premature optimization, avoid that. Get your code that works, make sure the code is stable and in production and has been stable for months before you come back, and then try and improve the performance of it. You probably don't need to. But if you do, wait until it's stable. Don't optimize something that's still working. Watch out for temptation. Resist temptation. So you know what I mean by this. New framework comes out. New package. We need to reverse a string, or we should go to NuGet and find a string reversal package. Or a new framework's come out that someone has that helps us do something that we could have done ourselves in 2 seconds. So quick, we're writing a Hello World application, install an IOC container. Again, why? Resist the temptation until it's needed. Or I read a blog post, I learned a new coding pattern, so now everything needs to be coded that way. I need to make all my code look like F#, because F# the best, because someone said so on a blog post. Oh, framework v2 is out. That's ironic. .NET Core v2 is out. Quick, we need to update everything. Rewrite everything from scratch. Why? Because .NET 1 suddenly stopped working. Obviously doesn't happen. Share what you learn with your team. Lift up the skills of everyone. Remember, one of the problems with tech debt is we end up with rotting skills and we age far too quickly and become COBOL programmers. Stay up to date. Share within your team. That's refactoring ourselves. Stay on top of what's going on. The fact that you're here is a good thing. You just got to make sure you take what you learn here and bring it back to others. Run hackathons. Hackathons are a great way to scratch the technical itch without doing it in production code. Do those things. I strongly encourage that. If you want to try some of these new things, do it, but do it in the context of a hackathon. Don't do it as part of changing your day-to-day code. That's not the mission. Adhere to your definition of done. Remembering that works on my machine is not done. That's you, I'm sure. And it's the whole product, not just what you're working on. And we are pretty much there. So remember, technical debt is a good thing, done properly. It's agile, iterative, incremental development. That's what we're after. Bad code, on the other hand, never is. So reduce your bad code and your technical debt through steady flow of small improvements. It's the best way to do it. Not sexy, not glamorous, not exciting, doesn't look great on a resume, but it does deliver great value. And prevent the bad code by getting plenty of eyeballs looking at the code, transparency. Stay disciplined, be professional. Don't respond to pressure poorly, as hard as that might be. And definitely don't respond to that by cutting corners, because that's going to be a problem. Identify and eliminate your waste, you'll improve your productivity anyway, and that's pretty much it. So, thank you very much. How are we doing for time? A couple of minutes to go. So, questions for anyone, preferably for me, but if you want to ask someone next to you a question, that's okay. Thoughts, questions?
One of the things you said was around avoid throwing it out and writing it from scratch.
Avoid the rewrite, yep.
Yeah. Is there an extent to that?
Sure. Okay, so valid business reasons are why. Don't rewrite just because it's difficult to work with anymore, if that makes sense. So a rewrite where, say, the technical stack that you built that old thing on was still VB6, for example, and you can't find VB6 programmers anymore because they all died. Or, basically the skills aren't in the market, no one wants to work on that anymore. That's a legitimate business reason to look at potentially doing a rewrite. However, it's not a rewrite. It's not a port or anything like that. What you're really doing is saying, if I'm going from VB6 to something else, I'm actually re-platforming and going to something completely different. So going from the desktop to the web means I don't take my desktop paradigm and try and apply it to the web, which is what happened a lot with those old VB6 desktop programs. And they just didn't work. And then people didn't have the skills there or anything like that. So they end up creating all sorts of other problems. So if you're going to do that, a re-platforming and a porting exercise is effectively start a new project with a completely different skill set. So you need to make sure that you pick a skill set that the team understands, that you're not also learning skills at the same time, because then there's just too much risk involved. You know, if you're going to do a rebuild or basically a new product from scratch with skills you've never used before on a team that doesn't have a lot of experience, what's your outcome going to be? So work within the skills you've got, do the re-platforming, that's fine. Questions, other questions? All right, if not, I will be around all week. Enjoy the veal, all that sort of stuff. Thank you very much for coming. Enjoy the rest of NDC.